Thank you for the invitation, and always happy to talk about this. I think it's a very interesting topic that still has a lot of interest and is ever growing. I gave a similar talk yesterday, focused more on the latter portion of what I'll be talking about. That's the incorporation of LLMs into the writing and synthesis. I gave that yesterday, and there were 350 attendees from around the world, with Cochrane Germany hosting that. If you attended that as well, you will see a lot of the same slides, but I've added some additional content here because I'm taking a bit of a broader approach. So this is going to be something that's largely qualitative and a mixture of my own experiences and thoughts alongside relevant evidence, because I do want to give a lot of references and things that to show all the work that's being done in this area. So I'll just start off by noting I am faculty with Cochrane Eyes and Vision. It's always worth mentioning in a talk related to evidence synthesis. And likewise, I'll note that since 2020, I've been a consultant with Pico Portal on different aspects of their platform. Pico Portal, I think some things are really paving the way on for AI integration and systematic reviews. And my involvement over the years has mostly been on suggestions for features and design from the systematic reviewer perspective. But it's given me some chances to really explore the boundaries of AI in synthesis. I'm not going to talk about Pico Portal anymore for this talk. I want to put it out there because it's relevant to AI and synthesis work. We all know the systematic review process, so I'm not going to spend any time really going over this. Suffice it to say, it's expensive, human resource intensive, and it takes far more time than expected every time we begin another one. So, that makes it pretty rife for opportunity for integrating LLMs and AI tools in general for helping us to streamline this process. So there are many systematic review tasks and places where AI can be incorporated. As more and more studies are done on these different areas, we're gaining more confidence about its performance. And there's still a big challenge that remains in that large language models they're not perfectly deterministic. They're just prediction models, and they're still largely black boxes. So it's hard to benchmark and ensure a consistent result will be achieved in every situation. And also know what exactly is going on behind the scenes. That's also quite difficult. However, with appropriate training sets and the right prompts, we're seeing more and more capabilities for their use and more than just screening applications. So these are some of the more recent studies on applications of large language models and their utility for systematic reviews, evidence syntheses in general. And then at each of sort of the stages that we're going to be talking about, I have more relevant information and studies that have been conducted on those specific areas. Before diving into really what we're going to be talking about, I like to put this up because I think it's interesting. I've prompted GPT before about what it thinks its own strengths and limitations are for evidence synthesis. I think it's an interesting self-reflection, and I agree with generally these points that it's making about its strengths and its weaknesses. So it knows or is able to predict based on literature that it's digested, that it's given its own capacity to interpret and work with language, it's most useful in tasks involving language and large volumes of text. And so the literature is expanding, but I think these are the most valid and fruitful, low-hanging fruits for AI given its current capabilities. There are also some weaknesses there, and I agree with these two. As predictive models, they don't actually understand the language, so they don't perfectly get nuances of things like directly making final decisions for assessing quality and biases or providing true interpretation of results. We may ask AI to find objective answers within text to help us reach conclusions about these things, maybe asking whether a trial describes the randomization process or asking whether the limitations of a study describe the potential biases. But I don't think, given these sort of more objective things, the systems are really yet capable of discerning what exactly that means when contextualized to the setting of the study, and to classify the risk biases or provide the implication of what a conclusion means for practice. There's still an area for development, though, I think, with more and more training data sets and examples of, say, risk bias assessments, it can definitely get better. So there's a couple slides that I have about things to think about, which I think are just good prompts for discussion as well, and to keep in mind as we're going over the material in these slides. And I do want to thank Karen Robinson for giving me these bullets. They've come up from other talks that I've done with her on AI integration and evidence synthesis. Are there potential gains? Of course there are. There are also potential losses. And, there's really trying to find the balance between these things. What kinds of efficiency do we expect to see? What's the trade-off in terms of how much computing power that requires, the potential environmental impact? Is that actually beneficial enough? Are the gains enough that it warrants that in terms of the efficiency, or is it too much, for example? As an outline of the areas that I'm going to cover, I will be trying to move pretty quickly through the systematic review process, and where I think the current capabilities and limitations are for systematic reviewing evidence syntheses. I was asked to sort of present maybe about the paper that we had published in 2023 when ChatGPT first came out, but LLMs have evolved so much since then, and so much more literature has come out. I'm following a very similar structure to that, but presenting a lot more what we know now in terms of its abilities. I'm also going to note that I'm focusing on ChatGPT just in terms of my own experience. And full disclosure, that's what I have a subscription for. But there are many other LLMs out there with different features and costs. And the supporting literature that I put up on the slides, they do evaluate a much broader range of LLMs than just OpenAI's ChatGPT. So I think these statements and these thoughts, about their abilities are pretty general and applicable to LLMs beyond ChatGPT. Other considerations, as I'm just flipping through this talk, these are other points and thoughts of discussion from Karen that I think are excellent primers, for discussion. So what do you need to see to trust the AI results? As more and more literature comes out, at what point are we reaching sort of a understanding and an acceptability for the integration, or are we already there? What's the biggest concern? How should we evaluate AI, and what are the appropriate comparisons to be made in terms of finding things like the validity and the accuracy of the approaches? And then what are the best practices for selection, use of, and reporting for AI? What should we do differently as we proceed into this newfound world? So one of the first things that I think LLMs has some utility for is helping getting started with drafting of the review protocol itself. Aside from the background, most protocols have a very structured setup. Whether you're working in an environment like Review Manager, RevMan, which is used by Cochrane, and that's extremely structured, or even if you're just free writing in Microsoft Word, all systematic reviews, the protocols, methods tend to follow a very regimented set of things that you have to hit. If they're following Prisma in terms of their reporting, that makes sense. So we all know the patterns and what to expect when we are writing the methods section. And interestingly, I haven't really seen any literature yet on its utility here for protocol development or for writing methods. Most of the literature that I've found in terms of writing and synthesis is focused on the after you've got all the evidence part and how can it help with putting that together. So because protocols can be quite formulaic, I think there's definitely untapped potential here in asking an LLM to get us started. So as with all things related to LLMs, what you get out of it will only be as good as what you put into it, and how good your prompt is. So it helps to be an experienced reviewer and methodologist, because you can ask for specific things that will tailor the initial draft to what you want. If I wanted to specify different databases or registries, for example, or add in different additional searching methods, it's easy to put that into the prompt. It just takes 2 minutes to write this up, and we run that. It's produced a good starting point for that search strategy and search process. And this hits all the things that I wanted. It also hits a little bit more. So one of the sort of the strengths of LLMs is how it interprets what your prompt is. And if it's a good prompt, so it will understand better, hopefully, what you're looking for, it'll supplement that and augment that. whether or not you tell it to. So you can see all I specified initially was the databases and working with a librarian. And just as an example of that expansion, you can see it's added a line also about tailoring search strategies to different databases and making the strings with appropriate keywords and medical subject headings, which is something I hadn't told it to include. An example of a task that's related to the search that was harder for the system to generate is search strategies. And this is something that I think should still be pretty much completely left to librarian and informationist. If the investigators, the reviewers have extensive training in search development, then that's probably okay, but I think you should still involve a librarian for the peer review of the search strategy. It's a really big question that a lot of people wonder about if LLMs can make good searches automatically, and that would be a huge help for getting started in a review. But I think there is a real risk there that I'll sort of highlight. So, in this question that we posed there, it's fairly straightforward, and the response looks generally at face value, to be okay. There's clearly marked mesh terms and keywords that will still be searched in all fields. There's Boolean operators combining terms within a concept with or, and then combining concepts with and. So the LLM understood the assignment. However, if you try and run that search, that from 2023, and then more cursory glance, there are some glaring issues with the response. So because it's a prediction model, it's predicting relevant items, and at least back then, it didn't really have access to the mesh database and structure, so it made up mesh terms that don't exist, or it put in entry terms as mesh. And it's created a filter for a study type, which was unprompted, but also correct. It's not a validated trial filter. This is an area where, the usability and the ability of the system to learn and develop with your own input is useful. If you, for example, told it to use a specific trial filter string and provide it, it'll replace that in the set. If you sort of told it that certain mesh terms are incorrect and replace them with correct ones, it would make those corrections. So through an iterative process, you can start off with a poor search and make it better. And running it again in 2024, it definitely, also I've run it again in 2025 more recently, got similar results. The search was a better starting point. It at least didn't include any fake mesh terms. But it's still an area that can be tested empirically and quite easily to see how sensitive AI search strategies are with existing completed systematic review questions and included articles. This is something that I think the real risk, as people have pointed out, is that if you are not trained in your search, right, search strategy development and search methods, you might just take those results at face value and try running that search and end up with a poor, non-comprehensive search of the literature. So studies have looked at comparing LLM generated searches with librarian generated searches, and librarians are always the searches developed by humans are always demonstrating superiority in retrieval performance compared with even the more recent and advanced LLM models. So they do recognize, I think there's a significant potential for workflow, even for example, translating search strategies between databases. If PubMed versus Embase have slightly different terms for the keywords like TIAB or fully written out title abstract. So a little bit quicker maybe in terms of shifting around how the search is going to be structured. But that's not just letting the search be completely developed by an LLM. So, generally the conclusions are LLMs for generating searches are not yet accurate or feasible, really. But there is still potential there as a tool for helping librarians work a bit more efficiently. And I think that's sort of one of the key aspects that I'm sort of going to be highlighting in all of the different areas for LLM involvement in evidence synthesis, is that they're tools for us to use and help us be a bit more efficient, but still not completely automatic. So, in answer to our original paper's question, are LLMs the answer for automated systematic reviews? I think the answer is no, but certainly helps us get through a little bit quicker. Another thing to note for this a bit specifically about librarians, is that in the multiple webinars I've given on AI and evidence syntheses, some of the most engaging audiences are the librarians, and rightfully so, because their expertise is not used enough as is, and they immediately recognize the danger in people using an LLM to produce something that they know is not going to be appropriate. So they want to get more involved in systematic reviewing in terms of both being involved in the review from the start, in terms of peer reviewing. So something to always keep in mind. The methods is another area where I think they tend to be pretty formulaic. There's only so many ways that you can write out to reviewers are going to extract the data and duplicate and then resolve discrepancies. And so basically asking for LLM's help in getting that methods section drafted is another, I think, really good opportunity. So doing that, a minute to write that little prompt, and it's writing up a nice start to our description. So including some initial common data extraction items, which I didn't ask for, and it recognized the risk of bias assessment and put in some extra information about the domains and overall rankings. So it's a great start here. It's similarly to the search strategy. I did run this again, just like last month in preparation for this talk, and it produced quite similar results, but less. So a bit more hit all of the same points, major content, but not as structured, a bit more and a little bit less in terms of words. I think there's two sort of reasons behind that. One is, of course, these are not deterministic models, so you're not going to get exactly the same thing every time you put in a prompt, which is good if you're using it for writing, as long as the content stays the same. But I think there's also been a push to really try and tighten up the responses that LLMs are putting out there in an effort to sort of conserve on computing power. So that's something that I think has affected all of the responses that I was getting from my prompts. All of them were definitely less wordy than my initial sort of attempts at getting some help writing. The last portion for methods is analysis, and this is something that is a bit more specific to the review. It's less formulaic than other sections of the methods, but LLMs are still useful. If you're a good methodologist and you know what to ask for, then it gives you a good starting point. So doing that, putting that in, it gave us text that we can easily work off of, how we can begin our qualitative synthesis, a fairly accurate overview of assessing clinical, methodological, and statistical heterogeneity, all the points that you would want to specify how you're going to do it. And then also a start to how we might conduct our analysis. So this also includes some standard language for sensitivity and subgroup analyses, which again, I didn't ask for. This is sort of a good example as well, though, of how this is really a starting point. And it's not something that you would just then copy and paste directly into your methods and just use as is, because there's criticism about this output. These are predictive models, and that means that based on the literature that it's digested in its training, it's going to give you responses that it thinks fit what you're looking for, regardless of if they're good or bad. So we know that we shouldn't select the type of model based on the heterogeneity, for example, but that's in here as a choice of model. So there's ways around this. You can be more explicit in your guidance when writing your prompt, so outlining exactly which model you want to use or how you want to choose which model to use. And then more importantly, of course, go in, revise it, make sure that it's actually checked for validity and says what you want it to say. So moving on from the protocol, once you're actually getting into the meat of the synthesis and the finding your literature, it's worth mentioning. I just want to put one slide up for or couple slides. Before LLMs, we already had an integration of machine learning, so a different AI kind of model. And there's already substantial integration of AI-assisted screening. So machine learning is incorporated, and the systems now learn what type of records we're looking for based on the titles and abstracts and how we make decisions to include or exclude. So we know this works. very well compared to random screening. There's been other people who've looked at this and found very similar results that I've found. Um, of course, what does that mean? How do we use that then? We're still a little bit uncertain about where to stop screening if we stop screening. How do we know that the model is actually working for those predictions while we're actually working through it? So I think a tool should give the user some estimate of how well the predictions are, the true positives, true negatives, false positive, false negatives, basing that on what it predicts for records and then how humans then subsequently screen those records. So that would allow users and will allow users to estimate positive, negative predictive values and sensitivities, specificities for how the model is doing. That can give a little bit more information to help decide if you want to stop or if you want to switch over to a single reviewer for the remaining records. Once you've hit a point where it's predicted you've captured 95% of the records and you still have several thousand left to go, maybe you can swap to one person, save some time there. But of course, that's machine learning, and interest, in this talk was mostly on LLMs. So we know the machine learning helps us screen faster. I think there's still some uncertainty about how good LLMs are at screening untrained, sort of with these zero-shot requests for finding relevant literature. So in theory, they're good at interpreting language, right? And if you give them a set of eligibility criteria and ask them to look through titles and abstracts or full texts of records, they can identify ones that are most likely to be relevant. We've looked at this with some projects, and other people have looked at this with projects, and it tends to be very variable. Sensitivities are pretty wide ranging, anywhere from 30 to 90%, depending on the question and how complicated those criteria are. I think it really speaks to, though, the overall point of AI assistance rather than complete AI, trusting it to do everything for us. And, in terms of the LLM retrieval, for a systematic review, finding everything, I don't think it matters all that much if LLMs are good at pulling all of the relevant records, if sensitivity is 100%. Personally, I think if you could take a set of 10,000 titles and abstracts and, distill that to the 500 or, 1,000 most likely to be relevant for your screening, I think that is a good starting point for your screening. And even if your sensitivity is as low as 50%, that means that you would still expect at least half of your includes overall to be included then after you've screened 1/10 of the records by that time. And combining that with the machine learning that we already know works well, by the time you reach the end of that set, your training set is better trained, I think, having more includes and excludes to compare than just a random set of articles as your starting point. So I think there's still utility there. And really the combination of those is what's important. So say we've got our final set of records then, and we want to move on to data extraction, risk of bias. So where's the utility there for LLMs in helping us get through? There's more and more of these studies every month describing how well LLMs can extract specific data elements. These tend to be pretty small scale studies in terms of the number of data items and trials being extracted and verified, but the results are usually pretty promising. And I think as we work towards better prompt development and standardization and sharing of prompts that work well, we will see larger leaps in the accuracy and also more willingness to have AI serve as the initial extractor with a human verifying the data, rather than two fully separate human assessments. So, for some of the items then I think as well that are more straightforward, extraction, country where the study was conducted, inclusion, exclusion criteria, those kinds of things. I think it won't be long and we can probably already just use the AI extractions fully to get those from the included trials with a random sampling for verification. The other facet for collecting data is risk of bias. And, again, here there are some small scale studies that generally find it performs reasonably well. Across studies, people are generally concluding that LLMs have demonstrated reasonable accuracy and consistency in evaluating RCTs, but it's mostly in terms of finding relevant sections of text. And that's where I think the most utility is. So to bring back an earlier point of one of ChatGPT's own self-appointed limitations, I don't think it's really that great at determining whether a particular passage conceptually and contextually places a trial at high or low risk of bias. But there is a good case, and I think a strength, for using it to find the objective answers to the signaling questions for risk of bias, and using that to then, more easily determine as a human what your judgment would be. It's also worth noting, I mean, there are specific LLMs and models that have been developed based off of the infrastructure for the main LLMs like ChatGPT as a framework, and then there are specific GPTs that have been developed using that and trained on more specific data. You can use those. It's also worth, I think, the LLMs just themselves do work pretty well, and can be just as useful as the base interface. So I wrote this prompt to create a table of study characteristics based on just abstract methods and results text that I fed into Scholar GPT, one of those more specific GPTs. And after that prompt, very quickly, I had a table of study characteristics, and checking it sort of for accuracy, based on what I had given it in terms of just the methods text, results text. It was pretty accurate. Green, lot of green on there, which I thought was exactly what I had asked for. Eligibility criteria, it was paraphrased, but I think how I wrote the prompt largely impacted that. Some of the characteristics there of age and sex, it didn't give me exactly distributed by the trial arm like I asked it to, but that information wasn't in the text that I gave it. They gave more overall estimates in the text. It pulled that out accurately. I did run this again, just uploading the full text PDFs now to just ChatGPT, and asked it to pull the same information. And there it was able to pull from the tables the more specific information, age distribution, sex distribution by arm, and that was more accurate. So I think that's one thing that's improved over the years. It's getting better at finding information, not just in text, but also tables, figures, that kind of thing. The last major section that I'm going to talk about is synthesizing the evidence and the potential of LLMs to help with this. So I was able to find a bunch of papers that seem like they're talking about synthesis and writing. But unfortunately, while these are describing different aspects of the LLMs for doing things like generating entire reviews without giving it a set of evidence, or providing summaries of a few papers, I wasn't able to find empirical studies evaluating how well LLMs actually write a synthesis or a discussion for a systematic review. So this is still an area where I think there should be exploration, and there needs to be some exploration. I think it could be done relatively easily. It would just take time, a lot of time and human effort to check the validity of the synthesis and make sure that the right comparison is actually being made. So for a couple examples of things that I think would be really interesting and help us answer the question of how LLMs perform in terms of how accurately they can synthesize and write something. If you took the results section that humans have already produced for a given set of studies in a systematic review, and you asked an LLM, you fed it the same data, right? The same tables and figures and full text from those studies, ask it to write a results section with the same kind of structure, compare those two, see how it did. Are there errors? Are there conclusions that are the same? What kinds of things is it pulling and highlighting, and see how that turns out. And a lot of the time in these papers and these studies, when they look at the synthesis, they do find there tend to be little minor errors. Sometimes LLMs will still hallucinate parts of their response, but the risk of that does come down when you are giving it specific data to use and to base its responses on. So the hallucination, I think, is more of a risk when you are just asking it to think outside the box or pull something from a non-specific set of data. Another example of a study that I think could be done fairly easily that would allow you to get a sense of how well LLMs are actually writing and discussing would be, again, take a results section from a human produced systematic review, feed that to it and ask it to make a discussion, hitting on all the points that we want it to hit on, see what it writes, and compare that to what humans have produced for the same set of studies and based on the same set of results. So that kind of thing, comparing the readability, comparing the relevance, comparing, see if it made any mistakes or things that were not true, the references it's producing to supplement, those kinds of things. I think there's value there. I just haven't seen those kinds of studies yet. In terms of drafting beyond sort of the methods and the actual synthesis, getting started with writing, we can use these to help us get started with our results. The description of the search results is something that tends to be quite formulaic. If you have a prompt, a general prompt like this, and then feed it a Prisma flow diagram, it will produce a section of text for you. I thought this one was particularly interesting because it sort of made an inference in that I had asked for the total number of records and how many were removed as duplicates. That information, as you can see, is not actually present specifically on this Prisma flow diagram, but it was able to back calculate based on the information that there were 2,208 from databases, 9 from other sources, and 2,202 records after duplicates were removed. So it added those up, gave me a total number, gave me how many duplicates were removed. And this text you could then edit, just check it for clarity and that it's actually correct. Again, don't assume that it's got everything right off the first bat. In terms of that synthesis and starting to digest the information, my own checking is basically in agreement, I think, with what other studies have found. So using a set of data from just 5 RCTs, asking it to create a little synthesis, and it's correctly grouping things as I wanted in terms of time points, 3 or fewer months, 12 or more months, giving a summary. This was also limited by the data that it had. So in the text that I gave it, it didn't have the specific estimates that I had asked for the synthesis. Those were found in tables. But when I uploaded the full text PDFs, then it was able to find the relevant information and include that. So another use case for writing, of course, is in plain language summaries, revising to simplify language. And so there are some other studies that have looked at this as well. And just again, to show for my own example, I think it works quite well. And the other studies also thought there was a really good utility here, just in terms of revising the language for grammar, for structure, as well as reducing the or increasing the readability, reducing the reading level. That worked quite well. And this was, I took an abstract from one of our Cochrane reviews and asked it to distill that down into a lower reading level. And I think all the main points are still there. It's just less complicated. So as we see more and more utility, and more chances and opportunity for integration of LLMs, we do need more guidance. And there is stuff that's coming out. There's people who are working on this all the time and more. There is going to be another session in the same webinar series that I just presented at yesterday, hosted by Cochrane Germany, at the start of June, let's say June 3rd or 4th, and that's going to have a joint sort of collaboration from Cochrane, Campbell, JBI, I believe, as well, another organization that does evidence synthesis. They're going to be presenting sort of their recommendations for using LLMs in writing and standards there. So it's something that I think more work still needs to be done in terms of mostly getting everybody who is involved in this area together to make the standards and set those and the guidance for people to be using. As sort of one example from those these are sort of 10 simple rules highlighted in a paper. I think they're a good point to end my presentation in terms of discussion for writing and the potential uses of LLMs. Following the rules of the target journal, that's very important because depending on the journal and publisher that you're looking at, they might allow LLMs for their use as long as you are explicit in how you use them. They might disallow them completely. Outlining the relevant risks before LLM use and pre-specifying those, right? Avoiding plagiarism and respecting confidentiality. That's really, really important for LLMs. I think there is a risk for any of the public ones as well. If you're just using ChatGPT, for example, if you were to put in text that is not publicly available elsewhere or put in medical data or anything like that, you really should not do that. There's no guarantee, and I think the assumption should be that it's not going to be kept private, and that it might find its way into responses that other people are asking for, or the ideas that are in that might then go back into the training set that the LLM is using. So that's something that should really be cautious about. And then verifying the truthfulness of that content. It gets things wrong, and you should not just assume that what it's given you in terms of content, even if you've written a very good prompt, is going to be correct. It still needs to be verified. So, humans, it's a human in the loop systematic review, evidence synthesis. It is not just completely automated by AI. And then there's one other rule here that it actually wasn't in as a specific rule within this paper, but it was sort of interwoven throughout. I think it needs to be explicit and stated as sort of that rule 0, transparency in terms of what models you're using, when you're using them, what prompts you're using, how you've used it, and how you've edited and checked the responses. The appendix is a great place to put all the prompts that you've used. I think that transparency is important, not only to understanding what has been done, but also for future people, to use if as a starting point. If you've got a really good prompt, there's no sense in somebody else spending a long time trying to reinvent the wheel and come up with the same good prompt. So that stuff needs to be put out there. So what comes next? I think it's fair to say the use of AI in systematic review tasks, it will quickly become the standard as a way of helping us do things faster for any evidence syntheses. But the human involvement is still necessary. The biggest thing for us to determine is how can we be more transparent in our reporting and clear about our decisions. All of those need to be pre-specified, and we need more and clearer guidance still on recommendations for use. These are things we need to do and keep in mind as we're working through replicability and benchmarking studies to better get a sense of what the abilities actually are. So thank you very much.